Okay, I've got 12:01, so we're going to go ahead and get started. I want to formally welcome everybody who signed on for our webinar. We are really delighted that you took the time out to join us today, and we hope that you would find this presentation to be stimulating as well as informative. We have three presenters today, including myself. So I am Sherrilene Classen. I am a professor in the Department of Occupational Therapy and the chair of the department. And I am also the principal investigator of the study. Today, I'm joined by Dr. Virginia Sisiopiku from the University of Alabama at Birmingham, and Dr. Sisiopiku is the co-principal investigator of the study. And then our third presenter is Dr. Wencui, also from the University of Alabama at Birmingham, previously from UF. And the three of us are going to tag team to bring the information to you. So what we are talking about today is the experiences of drivers of all age groups in accepting autonomous vehicle technology. And this is a collaboration between the University of Florida and the University of Alabama at Birmingham. So next slide. We are very fortunate to have received funding from STRIDE, which is, of course, the Southeastern Transportation Research, Innovation, Development, and Education Center. And you can also see on the map all of the other universities that's affiliated with Region 4 of the University Transportation Centers, of course, where STRIDE is housed. So Dr. Yang, you can actually also just go off video at this point in time. Thank you. Next slide, please. All right, I want to acknowledge before we start, of course, the funding agency, which is the funding came from the United States Department of Transportation, of course, through STRIDE, as I've just mentioned. Our project team, each one of the team members are recognized on the slide, and then we've had a variety of stakeholders in each one of these groups of individuals or individuals made this study possible, and without their support, their collaboration, their commitment, the study would not have been possible. So a big thank you to everybody. Next. I'm going to give a quick background on this study. So we do know that driving is a preferred mode of transportation in the United States. And of course, the task of driving, even though it facilitates autonomy and independence and helps us to complete and fulfill our roles in society, and participate into the community, there's an inherent risk involved in driving. And that's for drivers throughout the lifespan, younger, middle age, as well as older drivers. This is also further complicated that we will all, according to the work from Folly, outlive our driving lifespan with about 10 to 12 years. And so there's going to come a time that we will have to hang up the keys and we will have to start consider driving cessation. It's also very significant to mention this fact that globally there's 1.3 million drivers that die in car accidents every year. And we do know that about 90% of those deaths are attributed to human error. So we are very excited to think about the potential of autonomous vehicles, which we abbreviate as AV on the slide, and that autonomous vehicles may hold health and safety benefits for drivers across the lifespan, if these drivers accept the technology and adopt the technology. So in our own literature reviews, we've actually observed quite a few perceptions that's been elicited by colleagues and fellow researchers, but most of these studies pertain to the perceptions of the riders and not necessarily the lived experiences of potential riders. So in our study, we wanted to understand the acceptance of riders throughout the lifespan of automated vehicle technology, and we quantify that or operationalize that as the level 4 of automated vehicle technology, according to the Society of Automotive Engineers. And we looked at drivers throughout the lifespan. So we looked at their lived experiences and essentially conducted the survey before and after they've been exposed to the automated vehicle technology. Next. So the objectives of our study were twofold. First, We wanted to quantify the younger and middle-aged drivers. That was a group of 106 participants. We wanted to quantify their perceptions, as well as their values, beliefs, and attitude before and after driving a simulator, which was programmed to run in an automated mode according to the SAE guidelines level 4, as I've mentioned previously, and also after they were riding in a highly autonomous shuttle, which was also a level 4 according to the SAE guidelines. That was our first objective. Our second objective, we then wanted to take data that we collected previously of older drivers who were also riding in the shuttle and participated in driving the simulator. So we wanted to combine the data of the older drivers as well as the younger drivers to build a predictive model of facilitators and barriers from those data. So we had 104 older drivers, and they were 65 years of age and older. And we had 69 younger drivers between the ages of 18 and 39. And then our middle-aged drivers were 37 between the ages of 40 to 64 years old. So I will now hand over to Dr. Sisiopiku, who will talk to us about the methods of the study.
Thank you so much, Sherrilene. As with all studies of this nature, we started with getting the approval from the University of Florida Institutional Review Board for conducting the study, and all participants also consented to enroll and participate in the study. As far as participants are concerned, we had some inclusion criteria that are highlighted there. Potential participants had to be 18 years of age or older. They had to have a valid driver's license and have driven in the last 6 months. They needed to reside in North Central Florida, and they should not show cognitive impairment with a score of greater than 18 on the Montreal Cognitive Assessment. Those that qualified were enrolled, and they agreed to come for 2 to 3 visits in order to complete 4 15-minute surveys, or 15-minute simulated drive and a 15-minute shuttle drive as well. We implemented an experimental repeated measures crossover design where we conducted first the baseline survey. Then we exposed the participants to the autonomous driving simulator or the autonomous shuttle and completed the post-visit survey 1. And then we had the crossover, so we switched. So those that were first exposed to the driving simulator in the second visit were exposed to the autonomous shuttle and vice versa. And then they completed the post-visit survey 2. With respect to equipment, as Sherrilene mentioned, we had 2 modes that operated as autonomous environments. The one was the RTI high-fidelity driving simulator, and the other one was the autonomous shuttle. Both of them operated at level 4 automation based on the guidelines of the Society for Automotive Engineers. So I'll give you some pictures to see how those 2 modes looked like, and a little bit more detail on each one next. I'll start with the simulator. This was housed in the Smart House Oak Hammond location in Gainesville, Florida, and it is an RTI simulator. It is top of the line and integrates a full car cab with a 7 HD visual displays. We had created an environment that simulated an urban and suburban setting. The simulated drive had 2 parts. So first, there was the acclimation drive of 5 minutes. And this is important to enhance adaptation to the driving simulation environment. And then the autopilot feature was used that enabled for a 10-minute long automated drive. And during that period, the participants had to sit on the driver's seat, but were instructed not to have any manual control of the vehicle. As far as the simulator environment, it represented a low to moderate speed driving environment, 15 to up to 35 miles per hour speed. And as I said, it had both the suburban and residential area with some very realistic road infrastructure, buildings, and ambient traffic. The shuttle was the Easy Mile Easy 10 shuttle that was provided by Transdev. And this type of autonomous shuttle uses LiDAR cameras and GPS in order to survey the environment. And by doing so, it decides the best motion behavior at its instant. The shuttle itself can carry up to 12 passengers, 6 of them sitting and 6 standing. However, during our study, because of COVID protocols, we limited the shuttle ride to 2 participants per ride in order to be able to maintain social distancing. We also took extra care to provide safety and for our riders, our participants. And so the safety operator was on board and was responsible to sanitize the high-touch areas. And at the end of the study, none of our participants or our personnel had any issues related to COVID. Another thing that I would like to mention is that this type of vehicle is fully electric, and the participants rode at a low speed, and that low speed was less than 15 miles per hour. So with respect to the data collection, as we mentioned before, the participants were scheduled for 3 visits. The study team used pre-visit and post-visit surveys to quantify the perceptions of the study participants before and after being exposed to the autonomous shuttle and driving at the simulator that simulated an autonomous ride environment. So each participant completed a baseline survey and 2 post-visit surveys that had the same content with the baseline survey after they were exposed to those autonomous options. And the first visit was used in order to collect some demographic information, also to perform the trail making test A and B that determined if there were any limitations that would in the cognitive ability of the potential participant that would restrict them for participating in the survey. And a lot of work went into the what we call the autonomous vehicle user perception survey. And this is a visual analog scale for the purpose of assessing individual perceptions of autonomous vehicles. That survey has 28 items that were rated from 0, that was the completely disagree, to 100 points scale, which was fully agree. And it has also 4 additional open-ended items. And could measure 9 subdomains, and these include the intention to use, the trust, perceived usefulness, of the technology, perceived ease to use, perceived safety, driving efficiency, cost, authority, and social influence, and categorized into 3 subscales: the intention to use, the barriers, the well-being, as well as the total acceptance score for the AV technology. So after this first visit was completed, then the subjects were invited to come back and complete visits 2 and 3. And there, as I mentioned before, a randomly selected sample would complete first, which was classified as group 1, would complete first the visit to the driving simulator in visit 2, and then in visit 3 will be exposed to the shuttle. And then group 2 will be on the opposite order, first complete the visit with the autonomous shuttle and then be exposed to the driving simulator in autonomous mode. And at the end of each one of these visits, then a survey similar to the one that was given during the first visit will be completed. So the data were collected and processed using trained research assistants, and we're very thankful for their hard work. And they were stored using the research electronic data capture and analyzed in RStudios using the R version 4.0.2. And the data then, after they were checked and cleaned up, they were used, of course, for the data analysis. And the data analysis had 2 major objectives. The first objective was to examine the differences between the groups, the differences in responses between the groups, focusing on the younger versus middle-aged drivers. And we had 69 younger drivers and 37 middle-aged drivers for a total of 106. For this first objective, we ran a series of t-tests to assess baseline differences between group 1, which was those participants that were exposed to the simulator first, and group 2, participants that were exposed to the autonomous shuttle first, for 4 autonomous vehicle user perception survey scores. These were the intention to use, the barriers, the well-being, and the total acceptance. Then we ran a series of 2-way mixed ANOVA tests where we tried to test the main effect of group and time, as well as group by time interactions on the 4 autonomous vehicle user perception survey scores. And so I remind you, we had 2 groups, group 1 for simulation first and group 2 for autonomous shuttle first. And as far as times, we had 3 times: the baseline, the post-visit 1, and the post-visit 2. For our second objective was to develop predictive models of facilitators and barriers after cumulative exposure to the driving simulator and the autonomous shuttle, so after the post-visit 2. And for that second objective, 4 multiple linear regression models were conducted that were used to predict intention to use, perceived barriers, well-being, and the total acceptance score. And the independent variables that were considered are shown here on the slide: optimism, ease of use, life space, annual driving exposure, driving difficulty, the age, gender of the participants, employment status, marital status, and the race and or ethnicity. So for the next slide, I will invite our co-presenter, Dr. Yang, to let me just stop the share here to take it over and give us a summary of the main findings from the data analysis. Thank you.
Thank you, Dr. Sisiopiku. Okay, here we have the descriptive results of demographic data. Although we only focus on younger and middle-aged groups, here we still have all combined data sets for 210 participants here for demographic data. So for males and females, we have half and half. For education attainment, there are about 70% of participants who have bachelor's degrees and above, since Gainesville is a college town. So the education attainment for demographic data is a little bit skewed to the higher education. For race, about 60% of participants are white. And marriage status, half and half. For employment, about 1/3 of our participants are employed. For exposure type 1, simulator first, and the type 2, autonomous shuttle first, half and half. So for baseline, we first use t-test to detect the difference between group 1 and group 2. And the results show we don't have any significant differences between group 1 and group 2 for intention to use, barriers, well-being, and acceptance. The p-values range from 0.267 to 0.455. After that, we use two-way mixed ANOVA to test the main effects of a group, which are group 1, simulator first, and group 2, autonomous shuttle first, and time, which are baseline, postulated 1, and postulated 2, and the interactions between group and time. Here we can see the results for intention to use, barriers, well-being, and acceptance. We don't have any significant group effects. However, we do have significant time effects and significant interactions between group and time. So all statistics in bold are significant. So next, we break down the interactions by post hoc tests. First, we look at the differences between group 1 and group 2 at each individual time point. So for intention to use, barriers, well-being, and the acceptance, we don't see any differences between group 1 and group 2 for baseline or for postulated 1. However, at postulated 2, we can say for all scores, group 1, simulator first, has larger scores than group 2, autonomous shuttle first. Then we look at the differences within each group. So for intention to use group 1, we can say postulated 1 has larger score than baseline. Postulated 2 has larger score than baseline. Postulated 2 also had larger score than postulated 1. For group 2, postulated 1 had larger score than baseline. No differences between postulated 2 and baseline. Postulated 2 has smaller value than postulated 1. For barriers, group 1, postulated 1 had larger score than baseline. Postulated 2 has larger score than baseline. post-weighted 2 has larger score than post-weighted 1. Group 2, post-weighted 1 has larger score than baseline. Post-weighted 2 has larger score than baseline. No difference between post-weighted 2 and post-weighted 1. Well-being. For group 1, we don't see any difference between post-weighted 1 and baseline. Post-weighted 2 has larger score than baseline. No difference between post-weighted 2 and post-weighted 1. For group 2, post-weighted 1 has larger score than baseline. No difference between post-weighted 2 and baseline. Post-weighted 2 has smaller scores than post-weighted 1. For acceptance, group 1, post-weighted 1 has larger score than baseline. Post-weighted 2 also has larger score than baseline. No difference between post-weighted 2 and post-weighted 1. For group 2, post-weighted 1 has larger value than baseline. No difference between post-weighted 2 and baseline. And post-weighted 2 has smaller scores than post-weighted 1, sorry. So we're statistics in both are significant. We also test the percentage of score change among younger, middle-aged, and older drivers between the baseline and the post-weighted 2 for intention to use, barriers, well-being, and acceptance. So we use a series of Kruskal-Wallis tests, and the results display no differences. Regression model. For regression model, we use the combined data sets of older participants and the young and the middle-aged drivers. So we have 210 records, and before we perform the modeling process, we remove the 5 missing values. And here are descriptive results for the variables. Okay, so here are regression results. For intention to use, the model explained about 30% of variance, optimism, ease of use, and the race positively predict intention to use. Barriers, the model explained about 23% of variance, optimism, ease of use, driving difficulty, and the race positively predicted barriers. Well-being, the model explained about 36% of variance, age, optimism, ease of use, positively predicted well-being, while the miles driven per year negatively predict well-being. Acceptance. The model explained about 34% of the variance, age, optimism, ease and use, and race all positively predict well-being. Acceptance. Acceptance. So I will hand over back to Dr. Classen here.
All right, thank you, Wencui. So lots of results. So let's try to see if we can wrap this up with the discussion and then also with the summary and conclusions. So first, our sample had sampling bias. As we have mentioned, this sample was collected throughout the COVID period. So of course, people self-selected, and it's potentially only those who felt reasonably safe who participated in exposing themselves to our simulator and our shuttle study. So we do think that there is definitely self-selection bias, and in terms of the sample, as Wencui has showed, we could see that we had a group that was highly educated, majorly white, and also of, from the Gainesville, Florida area. I don't think he has showed the socioeconomic status, but they were at a higher socioeconomic status as well. So we had incongruence in the route between the simulator and the shuttle. So let me explain. During the COVID period, there was also the waiver recall from the National Highway Traffic Safety Administration. So essentially, we could not let participants ride in the shuttle on public roads. Of course, we wanted to continue with the study, and so we resorted to a bus depot that was basically desolate, not in use anymore. And that's where the shuttle ride took place for the older drivers. When we started collecting data on the younger and the middle-aged drivers, we actually could use the exact same route that we initially planned, which was in the downtown area in Gainesville, Florida. And I also just need to say that the simulator drive, the scenario, was modeled on that downtown drive. So we had very good geographic representation and the validation between the simulator drive and the downtown Gainesville drive. But the fact that the older adults' as data were collected in a deserted bus depot infused, of course, incongruence in our study and potentially some bias as well. So we think that these biases could basically have led to either an over or an underestimation of the participants' experience, and as such is not generalizable. Next. So the strengths of the study, we used a autonomous user vehicle perception survey with excellent to great validity as well as reliability. And I've got the manuscripts listed in our resources that we will provide to you if you want to read on how we established validity and reliability in the autonomous user vehicle perception survey. We also captured perceptions of 210 participants, and they were, as Virginia explained, randomly allocated to 2 modes of automation, pre and post exposure and collection of the data on their perceptions. We think that the simulator exposure can help us to understand not only the perceptions, but also, as we have showed, that there was an increase in participants' intention to use autonomous vehicle technology at the SAE level 4 after they were exposed to the simulator. So that may have a nice potential opportunity to conduct future AV studies on the driving simulator. And another strength of our study was that we worked with experts, particularly industry. For example, we worked with the TransDev personnel. We had a safety operator who knew how the autonomous shuttle works, and also that could interact in any kind of crisis or unsafe situation. Our collaborators were many, as we said during the acknowledgement of our collaborators. And so we are very thankful to the City of Gainesville, as well as the Florida Department of Transportation, who all provided support, either financial support or infrastructure support. And then the composition of our team was quite unique. We had individuals representing driver rehabilitation science. We had engineering, as well as occupational therapy. Next slide, please. In terms of the summary, so what should we take away from the study? Well, a quick synopsis of our results. The first finding is, regardless of the group, that's whether it was simulator first or autonomous shuttle first, the scores on the autonomous vehicle user perception survey increased after exposure 1 and 2, for both of these groups. So this is actually promising data, because higher scores indicated higher acceptance. So we feel positive about these trends that we have observed. Secondly, there was no significant differences between baseline and post-visit 2 for the 4 domains of the autonomous vehicle user perception. So no statistical significant differences for intention to use, barriers, well-being, or acceptance among the young drivers, the middle-aged drivers, and the older driver group. And this is actually refuted a hypothesis that we had initially, or an assumption, because we for sure thought that there was going to be higher acceptance amongst the younger drivers as well as the middle-aged drivers when compared to the older drivers. But that didn't hold true. As we could see, statistically, there were no differences. Third, optimism, that's a positive inclination to use either the autonomous shuttle or the driving simulator, as well as the ease of use of the technologies. And then the white race and the older age positively predicted the autonomous vehicle user perception score. So we may surmise that if folks are more optimistic, if they conceptualizing that they are going to have an easy time to use these automated vehicle technologies, if they are of the white race and increased age, that there's going to be more positivity in terms of accepting the technology. And then, of course, as we mentioned, miles driven, especially lower mileage, predicted negative well-being. And we think this goes hand in hand with the fact that lower mileage may be a proxy variable for many of the comorbidities that folks may experience if they are not really driving a lot of miles. Of course, that's what we surmise, so more empirical investigation is necessary to validate that postulate. And then in conclusion, so if we have to give you 2 points that you can take home, what is the take-home message of this complex and long study? First of all, that exposing drivers to autonomous vehicle technology promotes their acceptance practices. And this is generally speaking overall. So we feel that this is a very positive result. And then secondly, the positive predictors of user acceptance of autonomous vehicle technology, both the shuttle as well as the autonomous simulator, include age, the white race, optimism, and ease of use, which together explained about 1/3 of the variance in the total acceptance score. Right, next please. So we have published manuscripts, and we are more than happy to share any or all of these manuscripts with you. The first 2 manuscripts pertain to the validity as well as the reliability of the autonomous vehicle user perception survey. And we have conducted face validity as well as content validity, but we have also conducted construct validity and then retest reliability. The second set of manuscripts pertain to the driving scenario validation. So we have published that manuscript and Frontiers in Future Transportation. And that essentially showed that there is good content validity, face and content validity between the geographic configuration of the simulated scenario, as well as the downtown Gainesville area where the shuttle was running in its original route. The simulated driving scenario, we have listed the site where you can watch our YouTube video that actually filmed the entire simulated driving scenario. So we are happy to share that with you. The third group of manuscripts pertain to simulator and motion sickness with autonomous vehicle technology. And so this was really important for us to understand if we do know that simulator sickness is a byproduct, especially for older adults as well as for females, of being exposed to the driving simulator. But we were not quite sure if that holds true for motion sickness, such as experienced in the autonomous shuttle. So this manuscript helped to clarify some of those questions that we had. And so please feel free to read more about that as well. Next. So some of our other published manuscripts pertain to findings of this particular study that we have just mentioned to you. The first is the actual older drivers' experiences with automated vehicle technology that was published in the Journal of Transport and Health. And again, we are including the DOI number for you for easy download. And then secondly, we also looked at an interim analysis of the older drivers' results. And again, the DOI number is downloaded for you, which was published in Frontiers in Sustainable Cities. And then our third manuscript was basically looking at predicting autonomous shuttles acceptance in older drivers. And we looked at a few independent variables, particularly their readiness of technology, their life space, their driving habits, and also cognition. And that's been published in Frontiers in Neurology in the Neurorehabilitation Special Edition. And again, the DOI number is downloaded for you. Next, please. We have 3 published reports. 2 of these reports pertain to the work that we have presented today. And then the third report is basically, the study has been completed by Dr. Electriado and her co-investigators, and basically looking at public acceptance of autonomous vehicle technology also in Gainesville, Florida. And we just thought that it's interesting to include this report so that you can compare and contrast findings with what we have found in our published reports. Next slide, please. So we appreciate your time. We appreciate your commitment to be able to be part of our webinar today. So we would like to invite you to enter your questions in the Q&A section of this webinar, and we will be more than happy to answer the questions and to as best as we can. And then we also ask that you complete a very brief survey by clicking on the link that is provided in the chat box. Okay.
Well, you're doing that. We have a couple of questions already in the question and answers section, and these relate very much with the availability of this information. So the first question asks if final reports for this project have been already posted. And I would say that this presentation covers results from and compares findings from 2 studies that we have conducted through STRIDE. And so we have 2 final reports. The first one is a report for project D2, and it is already available on the STRIDE website. I'll be happy to put on the chat the link to that one. The second one is for project A3, and this report has been already completed as well, has been through the external review, and should come to that same site very soon, within, I think, a few weeks. So you are welcome to check those out, as well as check, of course, you know, the many other publications that Sherrilene shared with you that have even more specifics.
Yeah, I can just update by saying that the final report has been submitted, and it will probably be available in less than 2 weeks, probably any time now, depending on how fast Ondine can make it available for you all. But it has been completed. All right, the next question is interesting study. Well, thank you. And the participant asked, are you currently exploring the perceptions of individuals with disabilities? And the answer to that question is yes, we are. So we are actually right now in the stage of data collection, and we are collecting the data of 50 participants with physical disabilities, which include motor disabilities as well as sensory disabilities, such as, for example, low vision or being legally blind. We are not including people with cognitive disabilities because we do feel that this is a very different characteristic, but we are planning to do that in future. So last week in the update, it seemed like we are nearing about 30 participants as data, and so that study will still be continuing throughout the summer. And we'll be happy to share the results, of course, soon thereafter, once we are done with the study. So we also plan to not only look at the people with disabilities, but then to compare and contrast the findings of their perceptions with younger adults, with middle-aged drivers, as well as with the older adults. So it should make for a very nice comparative analysis and be quite informative in terms of the different cohorts and the different age groups. Thank you for that question.
I can take the next one by Joe Hammer. The question reads, what did the participant using the simulator do? Did they just sit there? And if so, why wouldn't they like that? And yes, the participants were instructed not to really drive anything. They just sat there. But you know, sometimes because we are people of habit and we like to have control. I mean, it is hard for somebody to sit in the driver's seat and not actually drive the vehicle. So perhaps that's why some people were a little resistant with that. Sherrilene,
very good. Thank you. Thank you. Yeah, and we also think, just to tag onto what Virginia said, that's why we are seeing that there was an increase in the scores and intention to use the driving simulator, because folks could actually have a virtual experience of watching that the steering wheel calibrated itself, that the gas worked by itself, that the brake worked by itself as they were sitting in the driver's seat. Whereas in the shuttle, they didn't have almost that tangible visceral experience. So we think that may be one of the reasons why intention to use increased for the folks in the driving simulator. But yes, so remember also that the simulator was programmed at the SAE level 4. So initially they did, during the acclimation scenario, they did start by driving, and then the automated function took over. And then just as it would in a real life level 4 SAE vehicle. Okay, so
another question asked about incentives, if we provided incentives for people to participate in the survey. And yes, because they had to be, motivated to come. So we paid each participant $25 for their time, for the 3 visits that they had with us. And I cannot answer the first part that says what is the response rate to the survey, because these people were really recruited. So it was not just a survey that was sent out. But we had to exclude several participants that didn't meet the criteria.
Yeah, I think that's important, that the folks actually completed the survey on site before they were, riding either in the shuttle or in the simulator. So we had 100% response rate because they completed it on site, pre and post, except for, there were some missing data points, so we had to exclude people, 5 people's data. Okay, another question is, Ondine, I'm going to ask you to please make sure that the links of our studies are being sent to the participants. Hope that is okay with you, Ondine.
Sure thing.
So thank you so much. And then it also asked, do you have any ongoing shuttle studies in cities other than Gainesville? And I'm very delighted to say a big yes. As a matter of fact, we just got the notice of award of funding from the Florida Department of Transportation, and we are going to continue looking at the user perceptions of older adults, which we operationalize as those over the age of 50 in 5 areas in Florida. That's going to be Lake Nona, Tampa, St. Petersburg, the Villages, and then Port St. Lucie. And so we chose those 5 areas because they are leading counties in terms of crash statistics in Florida. And we also are working with the industry partner that is willing to make sure that his shuttle, the Ollie shuttle, will be deployed in those areas. So the kickoff meeting will be held in 2 weeks, so hold tight. Information will be forthcoming very soon. Thank you for that question.
Wencui, would you like to take the question about the group time interaction? I see that.
Yeah, I can take this one. So for this study, we have 2 groups: the simulator first and autonomous shuttle first. So that's a group, right? So we have 3 type points: the baseline, post-valid 1, and the post-valid 2. So interaction means, so for between group 1 and group 2, their relationship can be different at each time point. For example, if at baseline, group 1 could have larger values than group 2, and at post-base 1, group 1 could have smaller values than group 2. So that's interactions between group and time.
All right, and then let's see, very interesting study and findings. Is there any relationship between previous driving behaviors, driving habits, and the perceptions of automated vehicles? So those data still need to be analyzed. So at this point in time, I cannot provide a definitive answer for that. We expect that there may be, but we have not analyzed that data yet. Okay. Okay, the next question is really fascinating research findings. Can you briefly share the STRIDE education outcomes? Right, I am not quite sure if I understand the question correctly. Let me take a stab at that by saying that we will have a transfer of technology report that will be submitted and published. And then we will also share the data via open source. I believe the open source site is Xanadu. And I don't know, Virginia, if you've got any other suggestions pertaining to the educational outcomes of our study.
No, I think this pretty much covers it. And we are, of course, available. If you need additional information, feel free to reach out.
Right. And then just, we are disseminating the findings through the webinars. And I've shared the publications with you on our first study pertaining to older adults and validation of the simulator versus the shuttle route. And then this particular manuscript that pertains to the findings of the work that we provided you this morning is currently, we are busy with revisions. It's been accepted with some revisions. So again, stay tuned. The study will be forthcoming in printed and in published, peer review published format very soon. Okay, what was the total funding for the study?
Tricky question.
Yeah, well, it was for the first study, it was about $250,000, and that was the older adults. And then for the second study, the younger and the middle-aged drivers were about the same, about $250,000, and that's total cost. And that's, of course, done through STRIDE as well as the Department of Transportation. Okay, I do not see any other questions at this point in time. So
there is a question on the chat, that last question, if there are any plans to increase the speed of the shuttle for future studies. And this is something that it was not controlled from us. So the shuttle had some limitation on the maximum speed. But I'm fairly sure as the technology is maturing and is, more widely available, the shuttles will have the capability definitely to provide speeds up to 35, 40 miles per hour.
Yeah, that's controlled by the National Highway Traffic Safety Administration. And so we cannot override the federal government and the rules that they are making. And that, of course, is a big inhibitor of people accepting the shuttle. And our findings did not necessarily show that, but in subsequent studies that we are analyzing data, we are seeing that speed is inhibitor of acceptance practices. So, but today we didn't focus on the shuttle speed. The report that I shared with you that Dr. Eletriado published, certainly they noted those findings that shuttle speed was an inhibitor of acceptance practices amongst the public. I also just want to mention that I see that, Virginia did put the link in for the strike reports in the chat. So if you are interested in having the strike reports, please see the link in the chat. Okay, am I missing any other questions, Virginia or Wencui, or did we answer all of the questions?
That's it.
All right. Okay, and Undine is just saying that we will include links to the reports and to the recording of this webinar within the next week. And that means that it will be all of the slides pertaining to our manuscripts as well as the reports as well. So you should have that within the next week. Right, then I would like to take the opportunity again to thank you for your time and for your interest in our work. And I would also like to again thank my co-presenters who really did a marvelous job in collaborating with us on this study. Dr. Sisiopiku and Dr. Yang, thank you so much for your commitment, your expertise, your input, and your dedication to this area. We really do appreciate that. And this is a true exemplar of team science, where we are all bringing our strengths, our gifts, our talents, you know, our best contributions to be able to do this work that is so important for the future. So thank you again to everybody. Thank you also, Undine, for masterfully doing all of the organization in the background. We really appreciate that. And from my side, I want to say thank you and have a wonderful rest of the day.
Thank you so much. Appreciate it.
Thank you.
Take care, everybody.